Man, just a year ago, my whole livelihood would have depended on arguing against half of what you were talking about.
And what do you think now, after being away from it for a year? And
You know, I watched that talk and I did take notes. And when I was at Cloud, I came from a world of open source, where this idea that we can democratize technology and you can contribute. And as someone who wrote code and took that responsibility to contribute, I've started some small projects, some libraries that other people use, and I know the responsibility that comes from not just contributing, but maintaining things for years. And there's this problem where you create something, it's just the beginning, and then other people weigh in on what they want it to do and what it wants to evolve to. And so when we say the cloud is broken, the thing that I internalize is like, how did it get broken? And it typically gets broken by the people you attempt to support. So when I joined the cloud as an open source purist, I came in as a contributor of Kubernetes and projects like it. What you realize is that when you talk to a customer that has lots of money, customers like governments that have lots of money, the number one thing that they ask for is make the new thing work the old way. Because they have leverage in order to make you do that. If I show you a better way of doing it, the thing you can do with money is say, well, we do it the old way. We can't use your platform until you meet us where we are. And as a huge cloud provider, when you target tens of thousands of customers with different regulatory needs globally, you end up shaping your platform to mimic what they need. Imagine doing this for 10,000 different customers who can afford the customizations. So you go from simple storage service like S3 to some multi-planetary scale object store that's hard to replicate anywhere else. So I'm always with this conflict of, when we think about utility computing, you remember before cloud, we used to talk about utility computing. And we have electricity, which is largely a utility. The drawback of a utility is that only large people can run a utility. Hydro dams, nuclear power plants. These things do not scale down so you can operate them in your backyard. But the trade-off is that the cost at utility scale means that even people in rural areas with a population of just a few hundred also have electricity. But it doesn't scale down to the person that wants to do their thing. And so we have things like solar panels and batteries that allow you to operate at a smaller scale. And that's where I see the relationship between open source and the cloud. Open source creates standards as well, like Prometheus. But you also have cloud providers that put so much into things like S3 that MinIO can now have an open source project based on that standard. So I kind of see it as this kind of gray area. And I think companies like Civo's job is to say, let's make sure that we always democratize this technology. There will always be big players that have outsized capital and ability to create things, but we also need the smaller players to be able to come in and keep everyone honest, right? And I think where cloud is at this point, 80% has been standardized. 80% has become a commodity. We're at the point now where companies like Civo need to take that 80% and democratize it so you can run it on premise. You can take those things. So the cloud is broken, but I think it got broke for a reason. And you all run this business. You all think about product all the time. You get those customers requests to say, hey, could you add an Oracle compatible interface to your database as a service? And you're like, oh, if we do that, then you end up looking like the very same cloud providers that you may consider broken.
I think what we try and do is work with customers to understand where they're coming from and shift them towards what we see as the future, right? So Oracle, I think, is moving now to more containerized services and offering things on an on-demand way. And it's an education piece about moving people towards the future is what we're
I hope
doing.
people are willing to pay for the future. Like, I was very surprised at how many people would cut a $100 million check to a cloud provider, but not send $10 to an open source project. This is a very real thing. If an open source project came to your company and said, hey, we're going to charge you $10 a month, you're like, ooh, $10. Oh, man, I don't know who's going to pay for that. What's crazy that we're not willing to fund the future that we all wish would exist. And unfortunately, that requires capital. Most developers I talk to, they like getting paid at their job, right? So when we see cloud costs increasing by 11%, a lot of y'all want your pay to increase by some percentage, or you feel like you're falling behind. So I see this circular movement here, but if you want the future to exist, You need to be willing to pay for it. And that could be in the form of contributions, that can be in the form of educating others, or cutting a check to the very people who pay people to create the future you want to see. So that's your responsibility. So if I throw it back into the audience, the cloud is broken because you allow it to be.
Just thinking about cloud complexity as well. I mentioned to you briefly earlier that, and I mentioned this yesterday, I think, in this talk, that in the old days, you FTP'd your files and it was very easy, and you could just simply just upload them, and you could, if you weren't happy, you could move them. And do you think we're going through this phase? Kubernetes obviously very complicated, starting to see abstractions and things, but are they coming at a fast enough pace? Are we in this world still of complexity, and haven't we got to solve that challenge still? And there are things happening, internal developer platforms and platform engineering and these kind of things. But what's your view on, are we there yet? Is AI going to solve these problems? Maybe not getting quite into the AI debate quite yet. I'm sure we'll get into it at some point. But what's your views on those challenges?
I mean, you can imagine the person with the horse and buggy is like, I have the fastest horse in town. And you can get to the next town in 3 hours. And you ask that person, how would you get to another country? They have nothing for you. They will long for simpler days where people went as far as the horse would go. If you want 3-day vacations in a different country, then you need flight. An airplane is complex. There's only few people in the world that can do it. One of the biggest companies in the world is having trouble doing it. It's a hard thing to pull off. Now, some people say we should go back to a simpler time, but then you would have to erase lots of other things. I wouldn't be able to be here if we didn't have that level of complexity. I think the challenge is who we're asking to operate these things. I'm looking at people that have a website, WordPress, 3 blog posts per year, running on Kubernetes. Stop. Why are you doing this? When you get a pilot's license, the first thing you do, you don't call Airbus and be like, what's the latest thing that's coming out? You don't. But in our world, some reason, we really believe that the latest and greatest technology, we should figure out how to bring it in-house and run it ourselves. This is a mistake. Not everyone needs every solution because not everyone has every problem. But I do understand, though, because once the status quo changes, does everyone need Linux? But the status quo is that Linux is there by default. So you're using this very powerful operating system that's infinitely customizable just to run a web app. Is it overkill? So I think we're at the stage of maturity. So Kubernetes, I'm so glad that it came out the way it did. It showed you what a distributed system was, not in theory, not in a white paper, but in reality. There's consensus algorithms. There's lots of moving pieces to this thing. But if you want to operate it, here's the cost. Before, these type of systems only came out in the cloud provider. You never saw them. Here's S3. Here's Cloudflare. That's it. That's all you got back then. That was one of the first times that the cloud gave you the control plane. And you have to make a decision. Do you want to run this yourself? And so I think even when VMware came out, you bought VMware, you got the control plane, you got everything as one singular package, and it was all proprietary. It's their stack. In the Kubernetes world, we gave you everything. When the cloud came out, we didn't tell you about the hypervisor. You just ran VMs and was hidden from you. Kubernetes took the opposite approach. You see all the pieces. And yes, to get to that level of scale, to take everything from the white papers and all those computer science courses and distill it into a few binaries on GitHub, that's just where we are. But this is phase 1, folks. Think about the next 100 years. Do you not think this will be easier? Do you not think that there will be a replacement for Kubernetes? So I think a lot of times we all measure technology based on our own lifespans, and it's too short. Docker was necessary for Kubernetes to exist. Kubernetes is necessary for the next thing to exist. You may or may not be the person who creates the next thing. But the one phrase that I love the most is that it's easy to predict the future when you're working on it. Anything that sucks about Kubernetes is what someone somewhere is working on to fix and replace. I thought Mesos was going to be here forever. Right? Remember Mesos Con? They had Apple uses Mesos, and you're like, we got 3 servers, we might use Mesos too. And now Mesos is largely gone. It's gone. Do you not think Kubernetes will have the same life cycle? It will eventually be replaced. So Is the complexity necessary in its current implementation? Probably not. Kubernetes also fell victim to the idea that you show up and you had an idea, the community is very welcoming. Luckily, we had extensions like CRDs, and a lot of that stuff lives in the periphery of the ecosystem. But if you ever went to that cloud-native landscape and get overwhelmed, right, there's 10,000 logging solutions. Now, some of you would say there should not be 10,000 logging solutions, but that is the price of freedom. There's only so many cooking ingredients, but there's millions of restaurants. In the future, I think there will be hundreds of logging daemons. They may all rally behind the same protocols. There will be thousands and millions of metrics companies, smaller ones, even regional ones and local ones, government-specific ones, and they may all rally behind the Prometheus protocol. HTTP didn't mean we ended up with one web browser. It feels that way sometimes with Chrome. I get it. But there are new web browsers standardizing around HTTP. So that's where I think we're going. So that complexity is temporary. If you have a problem with the complexity, you get a chance to collapse those layers and make something new, and then you get to be responsible for maintaining it and telling people no.
I think that's a really good point, and especially about the scale of who's operating Kubernetes, of everyone's been given this great Swiss Army knife, right? And they're creating problems that the Swiss Army knife may or may not solve. And I like your analogy of like finding something simpler that will allow us to run WordPress when you're writing 3 blog posts a year. You don't want to be spending more time managing the infrastructure your WordPress is on than writing content.
When I saw you all ship that appliance, I don't really tweet or retweet vendor stuff at all. I actually will not do a paid tweet, it's just not in my nature, and it's not very honest. But the idea that you can close the gap, because if you look at the cloud, a lot of it has gotten stale. A VM is a VM, a VPC is a VPC, an IP address is an IP address. The problem that I had when I was earlier in my career was just getting all those things to play nice together. And then we had this unifying API layer, this thing we call Kubernetes, these cloud-native principles. Now you've scaled them down to the point where I can buy a piece of hardware and get a similar experience. I can point Terraform at it and get a similar experience. The same one that the cloud provider's trying to sell me. That only happens every once in a while do we get these loops of innovation. Cloud providers outrun everyone, and then things get commoditized. And every so often in your career, the people selling the big stuff and the small stuff are selling the same thing. And that's just where we are right now. And so this is the period that you should enjoy. Everyone likes the hype part, where we're going to the conferences. Some of y'all have updated your LinkedIn profiles. I saw someone with a Kubernetes tattoo. I'm like, you better hope they never change the logo. If you got a Mesos tattoo, I'm pretty sure you're trying to get that thing covered up. But this is a really dope part to be in. After 10 years, we're at the point now where it's starting to get a little boring. The attention span for change has moved to like crypto and AI. And you look at this, where we currently are, this is your moment to make these things bulletproof, make them stable, make them the same default. And I think that's just what people are currently doing. So this is, I don't know, this is kind of my happy period as someone who's ever built anything, that part where we actually get the hype cycle away from us. And we get to make this thing solid so it stops being a bunch of problems, and we spend more time talking about what we do with it, not what it could do.
Yeah, thank you. I mean, there's a real joy I get when I see what we've built in the back end and what Kubernetes is powering. Of, you know, someone comes to us with a Terraform script and says, give me a Kubernetes cluster, and then I get the privilege of seeing it in the back end and seeing networks get created, firewalls, links between virtual machines, then all of the orchestration on the VMs to create another Kubernetes cluster.
Well, and that's how I know we're only halfway there. When you stop saying Kubernetes, that's when we make it. Who's running around talking about Linux and TCP/IP right now? That's over with. Like, it's just a thing that works. You put it there, you use it for your needs, and you move on. So when people stop saying Kubernetes cluster, thing is, Kubernetes, if you really, really do the math on like your entire infrastructure, it's such a small piece in that whole thing. You probably have more complexity in your Cisco switch than in Kubernetes. It's not easy to have a switch with custom hardware to switch packets at light speed across all the ports. It's probably far more complicated than deciding what node to run Java on. Like, we're overthinking this a little bit. Right, so when we stop talking about Kube, and we're getting there, I think we're getting there, And don't be afraid to talk about that next thing and put Kubernetes in its place. It's just one layer in this stack. And I promise you, it is not the most interesting layer if you look at how all the other things work. You ever seen how a CPU register works? You ever see what an actual modern software runtime does? This stuff is far more complex than what Kubernetes is. So don't get lost in the ideas of Kubernetes. Look at it as a tool in your toolbox. If we continue to make it mature and solid, it belongs there. And then you are still the centerpiece. Look in that toolbox and make sure you have all the right tools. And Kubernetes is just one of them.
Interesting. So we were talking before downstairs around sovereignty, and we talked about people coming off cloud repatriation. We've launched an appliance, as mentioned, but you see more of that. You see, obviously, we're hearing a lot about different laws and different things. And what's your opinion around sovereignty and privacy, and how that might drive change in how we consume infrastructure?
I mean, I've worked at lots of companies. I've worked with lots of companies. The truth is, most people have no idea what software they're running in production. Stop lying. You have no idea who wrote your YAML parser. You have no idea. You don't know who they are. You don't know what they're doing. So essentially, every time you do an update, it's a backdoor into production. Every single time you do it. What makes you feel good is that most of you aren't doing anything that critical. Seriously, you're very easy targets. Seriously. Delta was down for 3 days from a software update. And you think you're more suited to deal with those issues than they are? You might not be. And then the way this is going with the secure supply chain, where people for the first time at some point will start asking, who wrote this code? Today, you can make up a name, go to GitHub, pick a cat picture to represent you, and start contributing to software that flies your military's planes. Today. And then the next update, they will bring it in using Jenkins. Straight into production. And if something bad happens, we will try to figure out what happened and who did it. At some point, they're going to start asking questions. Who are you? Right? When you make medicine, who are you? When you make food, who are you? When you start a business, who are you? They need to know. I think, this is a wild prediction, may not happen, that at some point, people may want to know, who are you? Will we need a professional license in the future to write software? Who are you? Have you taken the oath that you should do no harm to the software projects? Why would that day not come for the software industry? It may. So I think when it comes to sovereignty, countries will start asking these questions. It was one thing for a country like Germany to import an SSL library, cross their fingers and hope for the best. When you start getting to, I'm going to import your country's LLM model, and this knowledge thing is making predictions and making recommendations on behalf of your own citizens, do you not think a government will say, hold on, we're beyond just implementing a particular function over math. We're talking about a thing giving recommendations, telling people the summary of your constitution, telling people what the laws are, right? There's been many governments that try to put an LLM in front of a government website to give people official information, right? If you're trying to understand the rules and the law and you get a bad summary, whose fault is that? So at some point, I believe that software will become even more political than just the open source license you pick. These things will be encoding cultures, rules, and laws. And as we start to use more of these machines in these higher level systems, right? I think some people take issue with the way credit is reported. Should this person be able to get a loan? What happens if someone says you should be free? Did you commit this crime? Should you be allowed to drive? What should your insurance rates be? So I got a feeling as tech gets closer to politics, the rules will change. So yes, there will be a lot more cloud providers in the future. There will be a lot more software companies in the future, mainly because I think most countries will not outsource their entire IT infrastructure as we've done in the past.
I think that's really interesting. There's a few examples we've had recently with the outage that Microsoft had with the security update that went out. There's the recent vulnerability into SSH, which is exactly your point of someone on GitHub contributing something to SSH that started leaking keys out. And it was only someone in Microsoft who spent the time going, hey, why is it taking a few tenths of a second extra for us to log into our systems, that made them start digging into that supply chain of where this change got introduced.
And it's not the outages. I think there's a lot of companies that were focused, too many people focus on number of nines of uptime and reliability scores. You are going to go down too. You're not going to probably do better than some of these services from a reliability standpoint. The thing is, the thing that makes it feel bad is when you can't fix it. Right? There are a lot of people in this audience that are paid to have answers. And so when a server goes down, that can happen to anyone. That is not someone about being incompetent. But the part where you sit in the window in the war room and you can't answer any questions other than Azure's down. Why am I paying you for? Aren't you supposed to be the person that can fix it when the time comes? I think that's so part of the shared responsibility model when you tell my people that they can't fix it anymore. And there are going to be situations just from a human, it's not going to even be pragmatic. It's not going to be logical. When you do the math on paper, it still works out better to take some downtime with the cloud provider than have double the downtime with yourself. But it doesn't feel right to sit in a room and not be able to do anything about an outage. And I think that's going to be the biggest driver. And you can scale this to the sovereign play for governments, or it can be you as a system administrator responsible for the servers for your company. You can't dissolve this piece around, I can't do anything about it. So I think cloud providers will do a lot of work. When I was at GCP, we got a lot better at explaining the shared responsibility. Here's what we do. Here's what you have to do. And I think that's going to get a little bit clearer as time goes on.
I think it's a challenge for smaller providers as well, or even sovereign providers, of getting to that level of maturity and gaining that trust that GCP, Azure, AWS have had years of experience to say, this is our responsibility model.
Yeah, cloud is expensive because they're not selling VMs and software, they're selling insurance policies. Insurance policies are expensive, meaning I'm willing to give you something and take responsibility for it. We'll always have a premium. It just decides who wants to pay the premium. Do I pay the premium to you, or do I pay a premium to the provider? And that's the delicate dance.
Interesting. So we talked off stage as well about making this a bit more interactive. So we're not going to do a microphone, but I wonder if someone wants to throw a theme out or something we can discuss. But we said we're going to talk more about the future of tech, so maybe focus on the future.
Any questions from the audience? Here, I'm going to run up and give you my microphone. Oh, you have one. Don't throw it. We don't have that kind of coverage.
Hey, Kelsey. So you mentioned earlier that Kubernetes will not be here in 100 years. And I agree. There's no way it'll be here in 100 years. But I also can't find its ceiling. And I want to know your opinion about where the ceiling of the Kubernetes technology could be. I spent my whole career waiting for something that could unify all the software. And I feel like we have it, and I don't see where it stops.
That's a beautiful question. What's the ceiling for Kubernetes? If Kubernetes is here and the talk of a town in 100 years, we've done something dramatically wrong. Would you agree? Like, wow.
Sure.
All the thinking in 100 years, that's the best we got? Wow, that'd be pretty sad. So when I was at Puppet Labs, I remember I joined Puppet Labs in 2012. I'm working in financial services, spent 3 years, got Puppet in production. Like you, oh my God, this configuration management thing is a game changer. I'm able to specify a server and watch it come to life. We should do this to everything. And then I get to join Puppet Labs, and I'm like, now I'm in the mothership, where not only am I doing this for one company, get it into production, I get to do it for the whole world, and I get to shape these tools. And I remember about a year in, Docker came out. And at Puppet Labs, you couldn't say containers. We thought it was going to be a fad. It didn't account for configuration. It was just the app part. What about all these other concerns? And I watched the whole world move away to that world of rethinking the abstractions. At that time, the configuration community only saw automation. They didn't think of new abstractions. Think about this. Containers didn't come from system administrators. We were so deep in looking at automate all the things that we didn't ask the question, why are we having all these things? Can we not collapse those layers down to a better abstraction that didn't require tarballs, unzip, RPM, deb, if Windows, then do this? That was our whole world. And then another group came and said, well, stop playing around, man. Container image, regardless of OS, make it work. So Kubernetes, think about it. It's a very thin abstraction over VMs and existing runtimes. That's what it is, right? And it takes patterns of old. When I think about most technologies, they're usually a 10-year checkpoint. Things we've been doing for 10 years get checkpointed. So when we talk about Kubernetes as the future, no, Kubernetes is a snapshot over the past. We kind of pick best of breed, and we put them in one system, and we gave it a name. So Kubernetes is a 10-year-old checklist. The next checklist, what will happen? Think about what the ML community is doing. They're pushing so much data that they need to change the network. They want the network not to be 100 gig. They want the network to be as fast as a PCI Express slot. There was no change like that happening with web apps. They're trying to change the physical layout of a machine to not be one physical board that you stamp out, but to be a motherboard that stretches across landscapes. That's a whole different thing we can't even imagine because our workloads don't demand that kind of rethink. So the thing that will come is that there's someone saying, these are the things I cannot do with Kubernetes. So you're right. There's a bunch of stuff that we were doing with shell scripts and Terraform. We made a huge mess for like 30 years. So when you look at Kubernetes, it's like group therapy. Like, hey, this is what we were trying to build if only we knew how. So we're here now. But then when you look at all the things you cannot do efficiently with Kubernetes. So if you want to see the ceiling of Kubernetes, ask what you cannot do efficiently. Then you start to see Kubernetes start to crumble. It has no awareness of I/O, disk I/O or network I/O. It just places things and crosses its fingers. Also, Kubernetes is a Band-Aid over systems that are not very aware of themselves. If you say Kubernetes deploy Postgres, and Postgres loses its disk, that's a wrap. It's unaware, right? So you have to still orchestrate things back into play. And CRDs will give you a framework for creating more, not bash scripts, but more automation. But then when should the abstraction change? That's when you get databases like CockroachDB that start to be aware of not just cluster membership, but geolocation with data. You can say insert into table where country equals Germany. And the data store is aware of where those partitions live. See, that's the difference between automation and abstraction. So Kubernetes already has a very clear ceiling in my eyes. Now we need the other systems that are not within Kubernetes domain to just get smarter. So at some point, Kubernetes will have a less of a job to do with mounting volumes and unmounting volumes. This is just a today thing. So in 100 years, hopefully these systems will be a lot smarter. Hopefully these libraries and frameworks will be a lot smarter to where maybe Kubernetes will warrant a rethink, and we'll get it.
Thank you so much.
Any more questions? Or a theme we can throw out? I've just got a question at the front here.
Hi, Kelsey. So previously you were talking about, needing a license for authoring software because, humans should be responsible for contributing software to open source projects, stuff like that. On the other hand, we see more and more code being generated by AI. So do you actually see humans still writing code in 10 years from now?
This is a funny question because if you write in Golang, I was reminded of this when I was at CoreOS. I'm writing Golang, we're doing something, we're working on the CNI interface, the container networking interface that a lot of people use now. Me and a guy named Eugene. Eugene is a C developer, only written C. He works on kernels and low-level networking protocols, joins CoreOS, and we're like, everything must be written in Golang. And he was very frustrated. He's like, oh man, you guys are making a mistake. And so we're writing CNI, we got some weird bug with the way we were calling the system call. Eugene looked at the assembly output. He said, Kelsey, I found a bug. It's in the Go runtime. I was like, dude, what are you talking about? You just don't know how to write Go code, let me show you. And it turns out he opened an issue, and it turns out the way Go switches code routines and threads, it will do it in the middle of a system call. And you can't do that. You can't restart and then expect the kernel to behave correctly. And so they fixed it. And it fixed a whole bunch of bugs in Docker, in networking, and a bunch of things. Most developers don't write a lot of code today or 10 years ago. You write high-level code, and you ever seen how much code your compiler emits? Most people can't read assembly. Most people don't know how registers in an ARM64 chip work. So most people don't write code anyway. Most people are describing what they would like the machine to do, and they go through a lot of trial and error. We call it unit tests or something, to see if it will work. You ever write code, and you're like, oh, it works. Oh, my God, I must be good all of a sudden. No, you're lucky. So when I think about ChatGPT and Claude and all these things generating code, what's the difference? Instead of writing some dialect of Golang or Java, you're going to write in some human prompt, and you're going to do trial and error until it spits out something that works. You're going to find out it doesn't work, and the limitations of your prompting to make something work will define it as just another programming language. What's the difference between the way some people think about ChatGPT and Smalltalk, where you were typing things live and watching it live do something? So to me, there's still the semantic of humans describe program. Ideally, your compiler or ML model or autocomplete in JetBrains IDE will try to help you out along the way. But at the end of the day, these are decision engines. So will humans still try to serve each other and make decisions on how our tools work? Of course. Microwaves didn't get rid of restaurants. So I don't think the tool that you use to generate code will be no different than a compiler generating assembly that runs on a hardware CPU. These things are hard to do, and I'm hoping that ChatGPT makes it easier for more people to be better at programming, the same way libc made it easier to talk to the kernel and make system calls.
Thank you.
One question back there. How are we doing on time?
I've got 15 minutes.
We're doing good.
We are, yeah, plenty of time.
Is he allowed to ask a question?
We've got
Yeah,
one.
you can ask a question.
Yeah. We'll come back to you, Canal.
We're going to start a bidding process. How much would you like to pay to ask?
Hi, thank you for your interesting talk. I'm thinking nowadays, or from the future, from the past until now, people are doing more specific things instead of general things. In the past 1,000 years, people do everything by themselves. Now, you have workers, you have different career. Before, 10 people build a car, let's say. Now, you just only need to focus on one part of the car. And this is more efficient. In the tech world, I think it would work more efficient if you only focus on one point and be the expert. But I'm also aware that there are so many different things coming out, and you have to be aware of, you have to learn different new stuff. And I'm honestly overwhelmed sometimes. What's your opinion? How could you be expert in one field, but also be aware or at least keep up with the trend of so many different things?
Yeah, this is a good question because I think it's kind of going back to your tech career. Like my own tech career, I started out as a generalist because I lacked the experience to be an expert. Right, some people say an expert is just someone who's made enough mistakes to know what to do. And that requires time and experience. So when we think about today's world, and also in software, it's very unique. When you figure something out in software, you have the opportunity to make a library or a framework so other people can just enjoy the discovery by just importing and starting from there. And yes, they can make a decision. Do I learn how Chrome actually renders a website? Or do I just learn Next.js to make websites? and you can decide how low that stack you want to go. Now, in our industry, if you're an expert in certain things, then that's a huge career bet. One, if you're an expert in how hardware works, there's very few jobs that do that. But a lot of the jobs that do that can be, some of them are very lucrative. So it's one of these things where I think you have to make the decision. But most people are more generalist than they give themselves credit for. Like some people say, I specialize on Linux. You tend to need to know about an operating system, how they boot, a shell, userland versus kernel space, eBPF. All of these foundational components combine into saying, I'm a Linux person. So you typically will say you have a T-shaped career. You go deep, and then you go broad. You go deep, and you go broad. And I think most of us invest in these traits based on our livelihood. What are the job postings? What opportunities are available? There's a lot of risk in going hyper-specific, but I do think it's a world where we're going to have to figure it out at some point. As frameworks get better, as automation gets better, what happens to all the people doing that kind of work? And this is why I go back to what I said earlier. Your job isn't just to write software. Your job isn't to just implement TCP stacks. Your job is to make decisions on how to help other people, AKA business, and then you use the tools necessary to get to that point. So you shouldn't be as concerned that there's not a lot of work creating TCP stacks. There isn't a lot of work creating brand new kernels. You always will have the option to go explore that space. For me, I made some career bets. I went all in on configuration management at the right time. I also knew when to switch. So to me, I think it's more important being ready to switch when the time comes. That to me is far more important because we have no idea what the next level of specialization is going to require. Boy, is NVIDIA so happy that they're specialized in the type of hardware that they're specialized in. So it comes and goes. There is no permanence. That's the thing I think I'm getting at here. There is no permanence in your decision. If you go deep, go super deep, and you're going to leverage that depth for the next thing. The challenge is when people say, I'm a network administrator, and they refuse to learn how Docker works, even though Docker connects to the network. That would be my stance on it. Take your time, go deep over time, and it will look like you're a generalist.
Thank you.
We'll go here, and then I think there's a question back there.
Come down to Canal.
Hi, Kelsey. Great talk. Just wanted to follow up on the answer you were giving around folks using ChatGPT for software development. You see it on Twitter, like, you know, it's going to replace developers or whatnot. And now there are tools coming out, like my mom can just create a website, never written a line of code. So in the future, where do you draw the line with like professional developers and just anyone can write code? And my question really is, how do you see the landscape changing for developers and the future? Like, there are so many aspects to it. Like, how is hiring going to happen with this whole thing? And there was this recent announcement, the AI software engineer, I forgot the name, what was it called? But like, you give them like a ticket and they did all the things, and it was just a big boom on Twitter, like when they announced it.
Was it Devin?
That was Devin, yes. So how do you see that the role of a developer changing, like in the future, if you talk 10, 20 years? Like, it's only going to get more advanced. So where do you draw that line?
Look, I think the world has been very lucky. If you've been a developer, you could have gotten really far in your career with no empathy, no customer service, lack of communication, lack of hygiene, be in the basement, you hate people, but you love computers. And you could have got paid well. That's over. I'm not going to a restaurant without customer service. The food is great, but they'll spit in it. Doesn't make sense. You got to have, the bar is just being moved. Maybe there should have never been so much emphasis on writing the actual code versus figuring out what to write. How important is a designer? Lots of people produce terrible software, fast. And so I think what will happen is people will start to admire the essence of the complete package. There's a lot of small companies that are challenging big companies just on the usability. Right? It's just much easier to use. My Apple Pay is much easier to use than writing a physical check and hoping that it clears. There will always be room for this. So what is development? I think what we did was we said development is someone who writes code. And you can have a simple test. You walk up to any developer, the best developer in the world, and say, build it. And they will ask one question, what? It's the what that has always been what development is. If you want to build a building, you're going to have an architect, design, regulation, laws, who will use the building, how will they use the building. And I think the best developers in the world, they take big ideas and turn them into very simple plans that anyone can execute. So the design of this building was probably from elite talent. But the person that came and did the floor, they do floors all the time. It wasn't a hard thing for them to do their part of the job. So to me, software development isn't Jira tickets, open an IDE and start coding. It's all the things that happen to get to the point where the Jira ticket is accepted. That's what software development is. So you as a developer will have to learn customer service. You're going to learn how to use Figma. You're going to learn how to think about UX. And hopefully the tools will let you do that easier. I would like blind people to be able to use my application. What is the best way to do that as a developer? Housing developers do the same thing. They figure out what the regulation is around ramps and what the slope is in the degrees, and they drop them. Have you ever seen someone design a building? A lot of this stuff is like dragging concepts into place, and engineering saying, yes, we have the materials to do that, within the cost analysis, and then they distribute the work to professionals that have these specialized skills of creating ramps and stairs and putting lighting in place. We've been doing that for thousands of years. Software ain't that old. So I think what we're going to do is open the door for more people to be developers. Isn't this a good thing? That more people will be able to describe stuff that they want to see in the world and make it come true. The same thing was true about the printing press. What happens if everyone learns how to read? What are people going to do? Who's going to write the books? More people are going to write the books. So that's my stance on software development. This whole little hype wave, this is a very small blip on the radar. Right, wow, this thing's answering all my Jira tickets. Let it answer all the Jira tickets. Are you complaining that you don't got to answer Jira tickets? Man, sign me up. But the truth is, right now, today, it does not answer Jira tickets. It lacks the context to do a good job. That's what your job is. And when that thing can replace that job, let it. Let's go figure something else out, like being nice to each other, curing diseases. Cancer's still a thing. There's so many more interesting things to work on than web apps. We'll be fine.
Thank you.
I don't know, I really like Jira tickets. Like when you come in the morning and you've got a good list of what
You're the kind of person that has the Jira dashboards and workflows. You're the one that wants to run the Scrum meetings.
Oh yeah, it's just a highlight of my day.
Tell.
Hi, Kelsey. Thank you for coming to Berlin. It's great to hear inspiring talks from you, as always. Although you gave a lot of interesting points, I'm a little bit caught up in the part that you mentioned about the way they use Gen AI in the governmental systems. And you highlighted that it's quite political. On top of that, I believe it's not only political, but it's also a little bit ethical and definitely cultural. And in different continents, in different locations, I see sometimes optimism, sometimes pessimism with emerging technologies. And my question is, looking from different aspects, as developers, as engineers, where do we see the sparkle? Where do we see the authority? Do we need a new manifesto or something like that to define the norms? Or should we wait for an authority like a government or academia or businesses themselves to define them? We feel a bit lost, and you can't predict the future, but in your vision, how do you see it? What should we expect?
I think we have thousands of years of history to tell you what exactly the answer is. People will decide how they want to govern themselves. From religions to speeding tickets, there will be rules. Sometimes we will agree with the rules, and sometimes we won't. When we don't agree with the rules, some people have the power to change them through legislation or campaign donations, and others will protest. But either way, we try to update the rule book over time. AI is just another thing that the rule books will have to account for. So let's just make a simple example. You use AI to make a decision about someone's medical prescription, right? You just say, hey, drop your blood here. We're going to let the model tell you exactly the dosage and the medication you will use. And it causes harm. In society today, when we cause harm to another human and we can't settle it ourselves, then we go to the courts. So wherever the infraction happens, the court will decide. The same is true, like this idea where we're going to come up with 100 perfect rules around AI and never change it. That is wrong. The moment harm is done is when we will revisit the decision in the court. So I think a lot of people, us as engineers, we want a bunch of rules that we can live by, right? Kernel works this way. We have 127 system calls. We should do the same thing for AI, and then everyone would just use AI and not be questioned again. It's not going to happen, because where we're putting these AI systems is much closer to the human. And if you do them wrong, we're going to court. So if I come to you and say, hey, doctor, you prescribed me something that made my arm fall off. Look, my arm is on the floor. And you say, hey, man, not my problem. We're going to upgrade to ChatGPT soon. That's not acceptable. If we say, who is to blame? And you say, you know what? We're going to put this one computer in jail. I'm not going to be happy with one computer sitting in a prison. You want to have justice. And today we know that the price of justice is losing your freedom. And so a computer has no freedom that it's seeking. Humans do, as far as we know. And so I think when it comes to accountability, humans will never let go of this accountability component. Who authorized this machine to make this decision? And that person must stand behind it. To me, that is a fundamental rule, that no matter what we claim we want to do with AI, humans will ultimately decide when we don't agree, right? So this idea that you can generate music by using other artists' work, if no one complains, yes, it will just be a thing and we will all do it. But the way I think about generative AI, I think about, you know, the Olympics just occurred in France, right? The thing that makes the Olympics amazing is that you know how hard it is to do any of these events. Like if you went out to try to run 100 meters, it's probably gonna be embarrassing, right? It's like, man, let me stick to Vim and Emacs, not racing. But when we see a human break the world record, we're like, that's amazing, because you know your own limitations. But if someone were to just use steroids and they broke the world record, I wouldn't be as interested, because I feel like you're cheating. There's a reason why we put limitations on this. So when I think about generative AI and I hear a song from a machine, I can't identify with the lyrics because I know the machine did not live those things. You may say things that make sense to me, but a lot of artists that I listen to, I identify with them as a person that has gone through a similar experience as I am, and the lyrics become empathy. They become a memory, the lyrics. And so if you believe that a machine can do that, then so be it. But I prefer real intelligence. There's nothing in the world where I prefer the artificial version. I like my real heart. I will not trade it for an artificial one. And so I think that's where I think society will have to make its own decision. What do you want? But I do love generative AI as a starting point. I'm having trouble with this blog post. I would like something to generate a starting point as in my style. But I like the idea that writing is thinking. And so I would like to think over before I publish.
Thanks. I think we've got probably time for one more.
Yeah. First, thank you, Kelsey, Dinesh, and Mar, for this amazing session. I would like to go back to the supply chain attack. What would be your best advice to minimize them? Because I guess we can avoid it at all.
Yeah, so the question is, how do we minimize supply chain attacks? You cannot. Like when you think about the auto industry, how do you minimize car accidents? You cannot eliminate them all. But we can make them safer. We have seatbelts, we have VIN numbers, we have parts. So if one person has a problem with the car, we can notify everyone with that part, right? Because we have a serial tracking mechanism. So we notice that the brakes go bad in this car. Anyone in the world, if you bought a car with this VIN number, you probably have these brakes. We're not gonna wait until you get into a car accident to fix them. We can now be proactive. I think in the software business, we're kind of getting closer to where the automotive industry is today, which is the ability to do a recall, right? Do we all have to get hacked before we take something serious? So the last 5 to 10 years have been a good example. We identify a big issue, and depending on your tool set, you can do a query over your infrastructure that says, yes, we are running that particular version. Like if you're running Red Hat, you can say, yum, tell me where all these things are installed. Puppet and Chef can help you out there, and then you can go mitigate those things. Tools like container images make it a little bit easier to remediate, We found a better version if you want to accept it. We have a better way of making a new thing to be deployed and pushing it out. But the thing is, we still don't know who wrote it. So this part around trust and accountability, that part is still missing to some degree. I have no idea who did this. And I think that reputation component allows us to at least hold someone accountable, and then we raise the bar on what it means to be a contributor, right? Like these side channel attacks where someone is updating the makefile, like, wow, you're spending a lot of time on this makefile. What are you actually doing? Who are you? Should we trust you? Thing is, there's always going to be a new person that we trust that will do something wrong. How do we mitigate that person from continuously doing something wrong? And I think the faster we can mitigate these kind of issues, I think that's where people feel a little bit more comfortable. So like in production, I am not trying to make a system that never fails in production. I'm trying to make a system that can recover quickly when something inevitably goes wrong in production. Right now, there's a lot of companies that have no idea what they're running in production until the FBI tells them, hey, you're being hacked. Like right now? Yes. Right now, you are currently being hacked. You know how many customers I saw in that situation where we told them they were hacked? In the cloud, we used to have things that ran underneath in the hypervisor that would tell you that you're mining Bitcoins. Oh, that's why our cloud bill is so high. We've been mining crypto for the rest of the world. That is a sad state to be in. So before we zoom way too far in the future, we got to at least get to where the automotive industry is, where we can use a part, know where the part came from, have a chain of custody, where we can alert everyone that a recall should be done and hold people accountable when they destroy their own reputation. I think that's a fair place to get, and I think we're starting to make progress on that. I think we're out of questions here, but I enjoyed hanging out with you all. Very authentic questions. And when people ask me about what the future is going to be, I think it's going to be more like this, where we can kind of discuss the problems and the solutions. And hopefully in the future, the hardest part of the job won't be typing text into an IDE and praying that it works the first or second time. Thank you all.